Hi guys, Assalamualaikum warahmatullahi wabarakatuh and good morning. So today topic is process planning and design. So process planning is concerned with the planning of the conversion or transformation process needed to convert the material into finished product. So we already learned about product planning. So now when we get the product, we need to plan the process of making the product. So they call it a process planning when we do a conversion or transformation process when we convert the material into the finished product. So product planning consists into parts is process design and operation design. Okay. So process design is concerned with the overall sequence. Process design concerned is with overall sequence of the operation required to achieve the product specification. So you see here is to achieve product specification. And then process planning specifies the type of workstation. So process planning related to the workstation, the machine, the tools, the equipment that be used to convert to do a conversion, to do the transformation process to convert the material into the finished product. Alright, the sequence of the operation in the manufacturing process, normally we have a nature of the product, material use and quantities being used. So this is a sequence. And then the operation design is concerned with the design of the individual manufacturing operation. So we need to foresee the individual operation for the process to do a related conversion of the material or transformation of the raw material to the finished product. It consists of the examining man-machine relationship in the manufacturing process for converting the raw material into finished or semi-finished product. Okay. So I will go detail for this one later on. So the design of the transformation process required some framework. So the framework for the process design include what are the characteristics of the product. We need to know the characteristic of the product or service being supplied or offered to customer. So that is number one. Number two, what is expected volume, value output. What is expected value of output, the volume. What kind of equipment or machinery, equipment or machinery are available. So normally when we design some product, previously we have a process design of product design or planning. So we need to know the available tools or machine that available in existing line. So if not, we need to have some investment to buy a new machine. So that's why when we do a process design, we got the product detail, and then we need to know the equipment for be used to transform, to do a conversion for that particular process. So equipment or machinery, is it custom built, or we need to find or buy a ready-made machine or ready-made equipment. So that's why we need to do some homework. What type of level skill are available? So is it that required the specific level? For example, we need to do some welding process. We need to find some welder that very specific for TIG welding, for example. We need to find or is it they have that level skill in the line. If not, we need to hire a new one. So how much money can be spent of manufacturing process? How much money can be spent on manufacturing process? And how about to handle the material? So the material handling, so we need to plan also. Okay, system approach to the process planning and design. We have input, product and service information, product system information, and operation strategy. For correction process, we need to do a selection of type of the process coordinate with the operation strategies. Vertical integration studies consisting of the major or minor technological step, equipment studies, production process studies, and facility studies for the commission process. And then for the output, they have a technological process. They need to design or specific process and link and linkage among process. And there is technological process for the output and facilities. Building design, layout of facilities and selection of the equipment, personal estimate, skill level requirement, number of employee, training, retaining requirement, and supervision requirement. So that is all approach for the output. And the linkage between product and process planning. So product planning serve as an input to the process design. So product planning, we have learn about product planning, and then after we have that one, we need to use that is input for the process planning, because for process we need to design, we need to make sure the correct way to produce the product. So the engineer need to study how to convert, to do a conversion or transformation process, translation process to convert raw material during the process design. Responsibility for product planning and development rests with marketing department and R&D department. So basic product planning must begin during the product design. So normally when we do a product design, we already learned the previous days. I already explained during the product design, we need to do some material analysis, what material we want to use, is it suitable or not with the existing process what we have. So and then initially form for the material selection, and initially form as casting, forging, die casting, plastic molding taken place. So the basic process, and then if we know this one, the material using, we can relate with the process whatever we have in the existing one. Okay, so there is a basic product planning must be begun during the product design. Must be begin during the product design process. Okay, so here this is a product planning. After we finish the product planning, we need to do we have a final product. For example, we have a final product. So when this final product as we receive from, for example, R&D department, they give a new product as a new product, as a finished product for the production line to assemble, for example. So we need to use that final product, and then we design the process. So in terms of design, process design, we need consider the process design and operation design. So we need to see operation contents, operation method, and then workstation selection. That is how we do a process design. And the scope of process design, design of manufacturing of the product start with the receive of product specification and end with the final plan for the manufacturer of the product. The step involved in the process design area. So the scope of process design, one, carefully review the product design and product specification to ensure economical production is feasible. So we need to see the design, of course, and then specification. So during we have product design of the product, and then also specification of that product, what material they use, what type of the size, geometry. So that is all we need to carefully review for that one, and then determine determination of the method of the material that we'll use in the optimal manufacturer. We need to determine the method. So this is scope, and then selection of development and procurement of all machine, tool, jig and features. We need to see the available machine inside existing one, and then we need to define, either we need to find, we need to procure, we need to buy the new machine or tool, jig and features. And then layout of production area. So is it that suitable for the new product, making or manufacture or fabrication using the existing layout, or we need to use from the job shop layout to the continuous plan layout. For example, if we have a mass production, for sure we need to upgrade our for example, we have cell type production, so we want to make a mass production, so we need to set up a new conveyor, we need to set up a new line, so we need to have an installation of manufacturing facilities there. So the layout of production area we need to consider. Is it we have a space? If not, we need to do something. We need to plan our shift production. If we plan a high volume production, we need to do a 2 shift or 3 shift production time. So planning for and establishing the necessary control of material. Planning for establishing the necessary control of material, machine and manpower to ensure the effective utilization of manufacturing facility for economic production of product. So we need to plan. So this one important part also for production control, to plan the material, manpower, what I said before, when we know the production capacities and manufacturing lead time and production capacities, we can always plan the manpowers and also the shift or days of workings per month. So we can do a specific planning for that. Factor of affecting process design. So we have a volume of product to be manufactured, required quality of the product, equipment availability. This is a main factor when doing the process design that will affect the process design. And then a major factor affecting process design decision. So when we make some decision, we need to consider the nature of product demand and degree of vertical integration, level of product service quality, degree of automation, level of product or service quality, and degree of customer contact. This is a major factor affecting process design decision. Ultimately, the supply of virtually all industrial product and service is depend upon customer demand. So like I said before, in the pool or Kanban system, pooling system production or Kanban system, we need to refer to the customer demand. So customer orders, they will fix our process design that will affect our process design for the plan layout, for example, plan layout. So if customer order for the high volume production, high quantity, of course we need to initiate the new line, for example, because we cannot don't have production capacity to produce this one. We need to transform from work cell layout to the continuous plan layout. So they will affect the design of production plan, production layout. So the demand also affect the material orderings, the system, the manpower. So that's why we always consider the customer the demand to plan our layout, our production, our process. So we say that therefore industrial demand is derived demand. So there is derived demand. So like in the GIST, just in time system, we need, or Kanban system, Toyota production system, we see there is a derived demand. There is derived from customer demand. So it's follow the demand for company's product will be affected by the demand for some ultimate consumer product or service, no matter how far removed the company might be from the consumer market. So this is very very good if you can have this system, because we can eliminate our waste because of when we do this one, we can eliminate the buffering stock for production. So we just produce whatever required or demand by customer, and then ordering on the material also we can order just based on quantity that order or demand by customers. As we move further back in the change from the consumer, the number of companies in the particular industry reduce. Okay. For example, there are relatively few steel manufacturers, yet steel is bought and processed by many companies until there are thousands of companies producing consumer goods that incorporate steel in some way. Similarly, there are relatively few of oil extracting companies, but many companies further down change that produce goods derived from oil products. So we have in the conversion process, we have extracting from the raw material from the earth, for example. That is the main part. We get iron ore to produce steel. So there is only, for example, there is only one company that using or that do that one. So but when we see at the surrounding in that area we have several company that using steel to produce another part, to transform from the steel to goods that using that steel as a input production, similar to the goes to the oil extracting company. They have where a lot of oil products they derive from the oil products to produce the some product from the oil. The effect of all these are significant to companies that manufacture or supply industry good or service. The company needs to be aware of what is happening in its customer market, and those of its customers as customers, even though the company does not have direct access to this market. So this is will affect the factor that affecting the process design. And then others is a price manipulation. Price manipulation and others gimmick are not likely to have much effect. Not likely much effect on the total demand of industry product. If there is little consumer demand, there will be a low level of industry demand that cannot readily to stimulated by price or cutting. So there is a little demand for consumer, there is a low level for the stimulated by price. Also, because there are relatively few suppliers in the industry market, any attempt at the price war is likely to attract price retaliation. The net effect will then be to reduce profit all round. And then C, following on the A above, sale forecast must be largely based on customer assessment of demand rather than only upon a supplier assessment. Okay, type of process design. What is type of process design? So process focus production system. Process focus on production system. So this is a form of production system in which production operation are grouped according to the type of process. So product focus process system in this type, the production processing, the production department are organized according to the type of product service being produced. There is a group technology, for example, cellular manufacturing system. The group of the component are placed in similar facilities or familiars or group are separate manufacturing cell are used to manufacture this group. So I think this one already covered in the already explained inside the previous slide for the range production, low range, middle range, and high range production. We have also already explained regarding more cellular manufacturing system. This one is a relationship between batch size and then product design. There is in the relation for the batch size and product design. So this one also already explained before. So here we can see the batch size higher for the product focused dedicated system, but the number of production previously we used as quantity, the number of product design. Now previously we use a quantity of product, so now it's a number of product design. So same, actually they have lower quantity, lower number of product design for dedicated system product focus, because we just only focus for one unit, one type of product. So best size we can produce a lot of best size with the small quantity, a small number of product design. But if we use for lower best size, small best size, we can focus for product focus, process focus for the job shop. This is number of product design with a higher number of product design. Product mix. At point there is a single product having a large demand. In this case, a product focused organization dedicated to single product would be appropriate, which give low production cost per unit. As the number of product design increase, as the best size decrease, as the number of product design increase, best size decrease. Say in the point B. So here point B, this one point B. So when decrease, number of product design increase, product design increase, as a best size decrease, the size is decreased, because this one the best size, this is for the design. At a point D, the production of many, at a point D is here, D here. At point D, the production of many one-off, a kind of product, a job shop production unique product in best of a single item. It's a single item. You can see uh, the best size is for the lower, but the quantity, the number of product design, it can be higher. Production of many. At point C, the number of product decrease and the best size of product increase as compared to D. So cost requirement for planning design. The amount of capital required for the production system depend on the type of production processing organization. It is the greatest for production process organization and dismissed for the product focused based system. So economic analysis for production process, because fixed and variable cost, because fixed and variable cost to tend to differ from one form of production process to another. Economic analysis is used to compare alternative process plan for product production. So still remember regarding the fixed and variable cost. So the variable cost tend to depend the quantity of the product that manufacture, product of production. So if the quantity is higher, the cost is higher, because the variable is depend to the like utilities, manpower. So this cost always depend to the quantity of production. So for the fixed, they just a fixed cost like rentals, the building machines that we buy, that we invest. If no production, also we need to pay for the cost. There is different between fixed and variable cost. When deciding amount of type of production processing organization, it is important to consider the cost of each other. So we need to consider this fixed cost and variable cost when we do the deciding among the type of production processing. So cost function of the processing alternative, the amount of capital required for each type of process design tend to be different. So capital is investment for the fixed cost. We need to have some money amount to allocate for each type of process design tend to be different. So capital charge are fixed charge that occur every month. So I said just now, when we do an investment to buy a machine or equipment, or we rental the building for manufacturing some product, so we need to pay every month, because this cost will occur for each month. Even though we don't have production, we need to pay. So this fixed cost will be greater when initial cost of the equipment, building and other assets are higher. So when we invest a lot to buy initially, when we do initial production, we need to invest on that one. So if we plan for next production, always we consider the existing machine or existing equipment what we have in the line, so we can reduce our initial cost. And then the variable cost, which vary with volume different. So variable cost normally will start when we do a production for produce that product. So they will depend on the quantity that we'll produce. Normally when we do a initial production, we face on at the introduction stage, we produce not many products, so that time we have less of variable cost. But when we facing on the maturity or growing stage, we produce a lot of quantity product, so of course we need to pay more on the variable cost. So there is different between fixed and variables. So automated assembly line has as highest fixed cost. When we do automation, of course we need to invest more on the capital. we need to buy automated machine or robotic system, conveyor system. So fully automated machine to install inside the fully autonomous assembly line. Flexible, for example, flexible automation system (FMS). So we invest more on the fixed cost. So this is cost requirement for planning our process design. So when this chart also I already explained in the previous tutorial. So cost requirement, planning, design, we have discussed, we have annual cost for production and volume versus volume production. So we can see here annual cost for production is always related. For example, we can see here for the automated assembly. So they have higher cost for annual production for automated machine. But the volume production can be increased without increasing the cost. So the cost you can see like stable already. So no increasing, just small increase for small improvement maybe. But for the job shop, you see here, at the initial use, don't have no need to invest more on the cost, because maybe we buy one machine to produce the production also small at that time, the volume of the production. But when we want the volume of production, you can see when increasing the volume. So here, when we see at the high volume production, we need to pay more on the cost dollar here. So that's why for the job production, they depend on the product. So normally this time, this particular volume production, we always thinking to do a automate process, automation process. But if we have that plan in during our product design, because we can see during the product design the demand from customer, the market survey, so we can always plan to do automation assembly line with higher investment in the money, but we can still maintain the quantity for higher production without investment more money during the production. So that's why when we do this one, when we do a calculation for cost requirement, we can design either which type of production we want to build in our manufacturing system. And then break-even point. Break-even point and break-even chart we already did in previous slide in the tutorial, I think. So you can refer that one for that tutorial that is related to this slide actually. So this slide come later. So maybe you already did the tutorial, so you have some example or something in your mind to understand better on the break-even calculation or break-even explanation here. So the break-even point for the product, break-even point for the product is the point where the total revenue received equal total cost associated with the sale of product. So TR equal TC. So when we have this graph, we have cost and we have quantity. I think you still remember. And then we have this one, for example, fixed cost. So the cost of fixed cost we already have at the beginning, but it's always same for the fixed cost. So we have TC line. And then one TR line. TR line always start from 0. This one, for example, TR. I will explain later. This one TC. So TC is total cost. So this is a intersection. Intersection is this one. Intersection means TR equal TC. This one. So this point is always refer to break-even point. So this is referred to break-even point. Break-even point where the point total revenue and total cost is equal, intersection there. A break-even point is typically calculated in order for business to determine if it will be profitable to sell a proposed product as opposed to attempt to modify an existing product instead, so it can be made lucratively. So you can see here this is a break even. So the after this point, so they have profit, but before this one they have loss, so there is a break-even point. So when we have this chart or this calculation for the break-even point, so we can see either we need to propose a new product or we need to modify our existing. So we can do a calculation and then we can make some proposal to do a process planning or otherwise. So break-even analysis can also be used to analyze the potential profitable of the expenditure in the sales-based business. So we can also use the analysis to see the profitability, potential profitability. So break-even point, if the product can be sold in larger quantity, then occur at the break-even point, then the firm make a profit. So like I said just now, if we have this break-even point, so the quantity is larger than this point, so we can make profit for those after that point. So before this one, this is loss. This one profit. So break-even quantity is calculated by total cost divided by selling price minus average variable cost. So break-even BE always equal fixed cost FC divided by selling minus average variable cost. This one selling price we have in dollar, and then variable cost. So we have fixed cost. Fixed cost divided by total, this one selling minus by variable cost, we get the break even. This is a formula to find the break even. And then the profit, you have profit. So for profit, like I explained before, you need to find out from revenue minus cost. So what is revenue? Revenue is the total amount we can get after we do a selling. So for example, we sell the product for certain amount quantity, for example 1000 quantity. So of course they will multiply by 1000 with the selling price. So the selling price multiplied by quantity, so we can get the revenue. So more quantity we sell, we can get more revenue, or higher price. If we increase the price for the selling, more higher price with the multiply with the same quantity that we produce, we can also increase the revenue for the selling on that month lah. So either we increase the price or we increase the quantity to get more revenue. That is a revenue. But for the cost, actually I already explained this one. We have two costs here. We have variable cost and fixed cost. So for cost here, we need to total up from variable and fixed cost. So both costs we need to define before we do analysis. We do profit analysis. So for the variable cost, like I said, they always depend to the quantity. So more higher quantity we produce, more variable cost occur on that time, because the variable cost depend to the quantity. What is variable cost? Variable cost is like utilities, manpowers, material, what we will use in the produce that part. So they will increase when we increase the quantity. For example, we want to produce 100 unit nasi lemak. So we need to buy more brass or more rice, and then to hire more helper, amah, to do it, to help us in term of bungkus to manufacture the nasi lemak. So we will increase the cost on that one. So the time also we will increase. The utilities, the water, the electricity will increase by the quantity of nasi lemak we will produce. So there is a variable cost. But for fixed cost, there is normally already fixed. For example, we need some rice cooker. So if we want to produce 100 bungkus nasi lemak, we need 2 or 3 rice cooker more. So we will invest to buy 2 or 3 rice cooker to cook nasi lemak. So the investment to buy the machine, the rice cooker, is the machine, the tool, the equipment that we use to produce nasi lemak. So the tools that we invest, even though we not produce nasi lemak for the next month, we need to pay the interest or loan to the bank. If we make loan lah, if we buy cash, the cash will count as our investment on that particular month. So that is the fixed cost. So the rental of building, for example, we have a rental one building to produce some product in that plant. So we need to pay rental monthly. So even we don't produce yet for the product, we need already to we must to pay already the rent to the owners. So that is the fixed cost. So whatever the fixed cost, we need to count as a fixed, and then the variable we need to multiply with the quantity, and then this is a total cost. So the profit equal revenue, the selling quantity multiplied by dollars sell minus by total cost. So we get the profit. So when we do this one, we do the break-even analysis and the profit analysis. So we can see the either we can do a selling or not. We can make profit or not. If we can make profit on that particular amount price, for example, the selling price, so we need to increase the price, or we need to increase more quantity to produce, to sell. So if we produce more, we can get more profit. If we increase price more, also we can get more profit. But we need to lower down the TC, total cost. Total cost, the fixed cost already fixed, but we can lower down the variable cost, because variable cost also depend to the quantities. So if we can reduce the amount of electricity, water, material use, we also can reduce the cost. So this example, but I think the example for in the tutorial also in the previous slide also we already explained for this one. But in this example, you can see for 1,000 we need to produce assume the fixed cost for this product related equal into the basic cost for the business is $1,000 for fixed cost, and then they sell around 2 ringgit, the selling price, and then the variable, the selling of product is 30 cent. The assumed variable cost, variable cost with the associated selling price is 60 cent. The selling is 60 cent, and the variable is 60 cent, and then the selling price is 2 ringgit. So we can see there, this one is selling price 2 ringgit. We can see there, 1000 divided by this cost, selling minus variable cost. So we can get this unit as a break-even point. So we need to produce or to sell more to get a profit. If not, if we produce or we sell lower than this numbers, we can get loss. So we need to produce more to gain profit. So you can see here when we change the price from this one, from 2 ringgit to 2.3 ringgit, but the cost is similar, we get more or less number of the break even. So we rather than 715 for 14 for the break even point, so we reduce to 589 units to get break even. This diagram, break-even diagram, I think you already learned in our tutorial. Previously, I already explained in the previous slide. So you can see here, this is fixed cost line, quantity versus cost there. So you can see this is TC, total cost. This is revenue. So for this one, revenue and total cost, they intersect here. This is a break-even point for this one, and then this one break-even point here with this at B, this one at A. So you can see here the quantity for break-even A is lower than C when we have a revenue higher, slightly higher, faster. And then this one steady for C, steady, similar with the total cost. So there is take more quantity to get break even, but for the A, with the less quantity, we already get break even already. So you can see the difference revenue, but they make comparison with similar total cost here with different revenue R1, R2, and R3. So when we make a comparison, the R1 is more higher to get a break-even point with the low quantity. This one you can read, like already explained just now. So I think that's all regarding production process planning and then manufacturing cost and break even. So I think you can see this slide and then refer to the previous slide for the tutorial to understand the calculation part. Okay, thank you. Bye.